A ratio, isn't it like two numbers in an equation?
They can form a ratio of some sort. That's a good start. Any other ideas? I'm going to give you a hint. Look at 1/3. This is 1/3, or 1:3. This is actually a ratio. It's also a fraction, but you can call that a ratio. 5:15, that is also a ratio. Basically, any number that's like over another number or compared to another number is a ratio. We're going to check if ratios are proportional. A proportion. Say proportion on two. 1, 2.
Proportion.
Is formed by two equal ratios. So someone already said that in row 2. They're like, hey, I can do that mentally. Today's lesson is a bit 6th grade-ish, and that's okay. We're kind of starting at this like base layer to build upon for 7th grade. Look at 10/2 and 25/5. If you simplify these, what's 10 divided by 2? Whole class?
5.
That's 5. What about 25 divided by 5?
5.
Okay, so you can write 5 equals 5. If you have two ratios that simplify to the same thing, you can call this proportional. I'm going to put an arrow and say those, let's actually go to here. Those fractions are proportional. Proportions will always have the same unit rate. Say unit rate 1, 2.
Unit rate.
That was something we explored last week, and we're going to get back to it in just a minute, but today we're taking a bit of a pause. The proportions are read like this. 10 is to 2, as 25 is to 5. That's kind of the legal math speak. If I'm going to read those proportions, 10 is to 2, as 25 is to 5. That's just how you talk like a mathematician. It sounds kind of funky, but sometimes mathematicians are a bit funky. Yes.
So you know how we did that?
I'm going to pause you. It's about the aim.
No, it's about this. Where do we turn this in?
I'm going to pause that. Ask me after notes, okay? If two ratios form a proportion, they simplify to the same ratio. And that's what we did up here. We simplified 10/2 and 25/5. That was 5 equals 5. That's a proportion. Let's actually dive into a problem. I'm going to show you 3 ways of doing this same problem. The first way is going to be maybe, I don't know, the longest method depending on the problem. The second's a bit of a shortcut. And the third way is like the ultimate shortcut for some problems. We're going to identify if each set of fractions form a proportion, starting with 1/3 and 5/15. Well, I'm looking at those, and in my head I'm asking, can I simplify 1/3 at all? Is that as simplest as a fraction as I can get to? Yeah. So I'm going to write it down here. We're going to compare it. What about 5/15? What could I divide by? Back to unit 2, all the way in like September. Judah?
I think you can like simplify that to 1/3, so it equals.
What do you divide by, top and bottom? Prove it to
You
me.
divide it by 5, so the,
Great.
the top is going to be 1 and the bottom is going to be
Beautiful. Row 2, board of paper. So this is 1/3 and 5/15 is 1/3. If you can match them and they simplify to the same thing, here's your answer. Do they form a proportion? Yes. Your answers for all of these except for silver and gold today are either going to be yes or no, and that's kind of funky. You're used to having a whole number as an answer, but just know that you're asking today, is it proportional? Yes, this one is, or no, this one isn't. Let's try 4/6 and 16/18. Do they form a proportion? 4/6 needs to simplify. What could I divide top and bottom by? I can't divide 6 by 4, Cody.
2.
Beautiful. What does that simplify to, Hannah?
2/3.
Okay, so this is 2/3. Let's write it below. Does it equal, let's try to simplify 16/18. What can I divide by, Hunter? 16/18 is a bit of a funky one. I almost want to multiply it by like 4. Does 4 work for 18? No. What's the lowest number I can divide by?
2.
3.
The number 2 would work. Let's try a 2. 16 divided by 3 doesn't work. 18 divided by 3 does work, so I can't use 2. Or I can't use 3, sorry. 2 is the only one I can divide by. 16 divided by 2 is 8. 18 divided by 2 is 9. What do you notice about those two ratios once you simplify them? I can't simplify 8/9 anymore because 2 doesn't go into 9, 3 doesn't go into 8, so I'm stuck with that. Henry, what do you notice?
I noticed that, wait, what is that? Is it 8/9 or?
8/9 equals 2/3. What do you notice about the fractions? Are they the same?
No, because
They're
like
not.
16 divided by 2 would be, what's it called? It would be 6. Wait, no, it would be 8, right? Oh, it would be 8. That's confusing.
Yeah, 16 divided by 2 is 8. So this is not proportional. This does not equal that once you simplify it. Your answer for this is just a no. Is it proportional? Absolutely not. 2/3 never equals 8/9. That is where no comes in. Let's try C. This time I'm going to show you a semi-shortcut that isn't simplifying. Is 2/4 equal to 6/14? Let's jot it down. Instead of simplifying this one, if you don't like simplifying, this might be the tool you want to use for most of these problems. I'm going to ask myself, okay, does 2 multiply by something to get to 6? 2 times what is 6? 3. So let's jot that up here. If it's proportional, here's a cool trick. This is called the multiplication method. If I multiply 3 up here to get to 6, I should multiply 3 by that number to get here. If you can multiply it and it works, this is proportional. Let's try 14 times 3. Does that equal 42? Jot it down, board to paper now. Is 14 times 3 42? 14 times 3, thumb up for yes, thumb down for no. That was the goal. Summer, is that equal? 12 and 4. Because these both worked, you can say yes. This is proportional. You just checked it with multiplication. Let's try one more time with a multiplication method. Could you simplify 25/30ths and use that method? Sure. Do you have to? No, because I'm going to show you 2 more shortcuts. 5/7 is equal to 25/30ths. What's my first step for this one, Topanga? That looks like a 6. Try to multiply 5 to get to 25. What would you multiply by? 5 times what is 25? Okay. If you multiply by 5 on the top, you have to do the same on the bottom. Does it work?
Nope.
Is 7 times 5 30? No. This one is not a proportion because 7 times 5 doesn't equal 35. The answer is no.
Sometimes 6 does.
That would be 6 times. If it was 5 6, it would be proportional. Yeah. Okay. Try these 2 on your own in the next 30 seconds. You can use simplifying or you can use multiplication. Be careful up here when you get to 2. 4 times something doesn't equal 18, but you can do this. Sean, hands to yourself. 4 times 6 would work, and 4 times 4 would work.
But 4 times 18?
Yeah, you can't really do that. So I'm running into a problem with the multiplication in number 2.
So no?
Does 4 times 4 equal 18?
No.
Okay. That one doesn't work.
Are we just going on to the back side?
We can set the example 2 for the final shortcut of the day. It might make some of you happy. Number 1 is proportional, yes or no? Thumb up, yes. Thumb down, no. Number 1, what'd you get? Waiting on row 2, I need 2 hands. Number 1, Juliet, yes or no?
Yes.
Did you use simplifying or multiplication?
Multiplication.
1 times what is 5?
5.
And 2 times 5 is 10. So this works. It checks off. You can put yes. Could you also simplify 5/10 pretty easily?
Yes.
Yeah, divide it by 5 and you get 1/2. Both ways work. You can choose whichever one is the best for you in bronze that you want to. I'm going to encourage you, if you get stuck on one for more than you do one for 4 or 5 problems in a row, try to do another method, either multiply or simplify. The best mathematicians can interchange between all methods and choose the most efficient one. Your last and final method to solve proportions or to tell if proportions are true is called cross products. Underline cross product right here. Disclaimer, if you go to college or some mathy degree or go to a really advanced math class in high school, MIT would be one of them, the math professors there are not going to use cross products. They're going to say that is a bad method, don't use it ever. You may get in trouble for using it. I teach it too in 7th grade because I think it's useful just for the basic step-by-step what we're trying to solve. The reason they don't like it is because it's like this weird magic trick that you don't really know what's actually happening behind the scenes. And most math teachers just teach it like me, and you're like, whoa, that's weird. Why does it work? No one knows. The mathematicians that are like super smart in colleges know, and that's why they don't like you to blindly do it. For today, I'm okay with you just blindingly doing this magic trick that's called cross products, but if you get into high school, you probably are not using this very
Do
often.
you think I can make it to MIT?
It's off task.
Okay.
Here's how you use cross products. It's going to look like a butterfly. You probably saw this in 6th grade. And you're going to start with 2 times 10. You're going to multiply whatever's across. What is 2 times 10? Jersey, head up. Ashton, 2 times 10 would be? Okay. Then I'm going to cross product the other one. And whatever is across from 5, I'm also going to multiply. So 2 times 10 was 20. 5 times 4. Is that 20, whole class?
Mm-hmm.
What you just found is 20 equals 20. If you have the number on the left equal the number on the right, you can say this is proportional. Yes. Can you wait 2 minutes? Okay. Let's try the last one down here. Skip down to the 4th in the quadrant. I'm going to let you do these on your own. 1/6 equals 3/12. We're going to use cross product. Cody, which ones do I multiply first? Okay, what is 1 times 12, Cody?
12.
And what is 6 times 3? Keep going, Cody. Good. Does 12 equal 18? No. You just found that this is not proportional because this number doesn't equal that. There's your final shortcut called cross products that you could use. Could I have also set this one up with multiplication to solve? Sure. 1 times what is 3? 3 times 3 is 12? No, not at all. So I would also say it's not.